moving into our open hardware session. So Gavin, if you're out there, you're first up here talking about open source hardware possibilities from a manufacturer's perspective.
Great. All right, thank you, Adam. Hopefully that coming up there.
Yep, we can see your slides here.
All right, my name is, as Adam said, my name is Gavin McMeeking. I'm with a small instrument manufacturer called Haddock Scientific. I'll be talking today along with my colleague Emerson. We're based in Colorado, and we've been around for about 5 years and working on a number of mostly aerosol instrumentation for vertical profiling measurements and networks, things like that. And we were really interested when we first heard about, we have some DOE funding, both on some research projects. We're involved with this Rocky Mountain study that was just mentioned. And we also do a lot of SBIR and instrument development work as well, that's also funded by DOE. And sort of how that open hardware, the open science aspects fit into these projects is something we're kind of interested in. And, you know, we kind of come from a different perspective than I think most of the attendees, which is sort of the for-profit commercial process and how we can try to be aware of what's happening in the open science movement, and then also hopefully facilitate and help it succeed. And so today we have kind of just some sort of scattering of thoughts and things we've been mulling over even internally here regarding how open we should be. And before I get into those details, kind of just what open hardware is. Marcus kind of already discussed this a bit yesterday, but similar to how code can be open, the electrical schematics, the computer-aided design files of the mechanical drawings, the acquisition software and analysis software for hardware can be made available for either just visibility as well as modification and enhancement, depending on whether you're looking at open hardware or community-based hardware. Licenses exist that can allow for the redistribution, modification, and potentially even the sale of open source or open source hardware projects. And while we're not too familiar with those in the sort of atmospheric measurement world, though I'd be happy to learn about those, examples do exist more in the sort of makerspace hobbyist area with, of course, Arduino probably quite famously is an open source project. There's 3D printers such as the Prusa that are open hardware and that members of the community are able to build on and enhance. And so we've been thinking a bit about how that can work with scientific instrumentation. We first started working, basically this instrument, the POPS, a portable optical particle spectrometer was, oh, yep, sorry.
Sorry to interrupt, but I'm not seeing your slides advancing at all. And is anyone else having that issue?
Let me just, I had this issue the other day.
I am, Adam. I can't see them advanced either.
I just see the top slide now, so.
Okay, I'll just have to, it's a weird glitch. I'll just minimize before each slide. So just remind me to do that. Fortunately, there's not too many. So the POPS is an open hardware project that was developed by NOAA, or at least sort of a partially open hardware project developed by NOAA, intended to be a low-cost aerosol counter that members of the community could build themselves. We licensed it for commercial sale with the intention of sort of offering it to people who didn't want to make their own instruments. But there was some impetus at NOAA to sort of make this an instrument that many people could build. We've sold about 300. It's a popular instrument. It's used in a lot of different applications, and it has an international customer base. And if I do this, hopefully this will be a little bit clunky, but hopefully that slide advanced now. So it was, and after about 5 years of working with this instrument, it's been an interesting lesson for us in sort of how open hardware can work, because it's an open project, but it's not really emphasized as an open project. It hasn't been really managed in a way that allows users to contribute to the development. There are files, schematics available for people to look at on GitHub. But as you can see, there's not many people even watching this repository. It's unclear how many people are aware. We certainly point people to it when we get questions, but it's not, you know, I think it highlights a number of issues and challenges with open hardware where there needs to be a way to sort of manage the project and really a lot of sort of incentives and initiatives behind it. We've made some contributions to it in the early days, but we're also kind of debating internally how much of what we're working on should we be putting onto the open platform kind of maintain our business. If I go to the next slide, and then another kind of lesson with the POPs is it's really hard to work with open hardware. It's hard from us where we're selling the instrument. It's a lot of work to develop this instrument. This picture just shows lots of failed or screwed up instruments that we've worked on over the years. The changes, we're in software, you can make changes pretty quickly, though there is a time aspect of it. For hardware, you need fairly sophisticated computer-aided design software that takes time to learn. There's electronics software that's expensive to acquire and again takes time to learn. There's a big barrier to entry. You have to know a fair bit to sort of make a lot of contributions to the hardware. It can be expensive. There's lots of trial and error. And with hardware, you're buying things and they can be expensive and they can break and then you have to buy more. And so it's I think a different challenge from say open software projects. And there's a big question, certainly something we're thinking about is who pays for it? We're working and we want to be transparent and we think the science is better advanced by making our instruments and how they work as accessible as possible to people and folks who want to modify them. But we also have to be very aware that if we give away everything we're doing, someone else can come along and do the same thing and suddenly we're out of business and now we're not able to maintain the product at all. So we're kind of juggling with those. I don't think there's an answer, but we're interested in kind of hearing what the community is thinking. And so another thing with the POPs is it's a pretty complicated open instrument. And so we've been teasing and thinking about some ideas for simpler systems that Ethan's going to talk about now, which maybe are a better place to maybe really start a serious effort to make some open projects that can be used. So I'll switch over to Ethan now. Oh, and I got to do the trick, and I will do this for you while we go. All right.
All right. Well, thanks for giving me the chance to talk. And so what I'm going to talk to you about a little bit is, as Gavin mentioned, is a simple way that Handix can start exploring this open hardware concept. And so this is on the right, an image of a very simple diffusion dryer that we started making in-house for use with our continuous flow diffusion chamber to measure ice nucleating particles. And when we were looking around, we sort of said, well, let's make it so it works exactly for us in the way we want. And it was a combination of off-the-shelf components, custom manufactured perforated tubes, and 3D printed parts. And sort of we put it on our instrument, and the instrument went overseas to different campaigns, and people took a look at it and said, hey, can I have one of those? And we said, sure. And they started buying them from us. And so that's great. I mean, that's what we want to do. We want to sell things. But the thing is it's a very simple design. There's nothing particularly unique or that secretive about it. So, and there's a lot of alternative applications if you want to dry aerosol in a certain way or change the residence time. There's a lot of applications for people to do that, especially if we open up the design and say, hey, you can get these off-the-shelf components from here. This is our part number. Here's the custom manufactured perforated tube, and here are the 3D printed parts. And so anyone could modify this design, build their own. And if they just wanted it, they could just contact us and we'd be glad to sell one and ship it to them. But there are some downsides with the open aspect. Is not everyone can go contact the manufacturer of the perforated tubes and say, hey, can I have one? Because they're not going to do that. They barely like selling us 50 at a time. And a 3D printed part also requires a 3D printer and a little bit of knowledge of how to use that. I mean, there's ways to make it simple. And then it gets into this balance of like supported versus unsupported. Like how much effort do we need to spend to support other people making something that we can also just sell them? That would be much easier for us. So
you have to minimize it.
There we go. Oh,
no,
I'll try it. There we go. All right. And so this brings up this question of sort of an open hardware library for science. I mean, so should there be a scientific repository for open designs that anyone can sort of go and access, download the SolidWorks part file, an STL file, a step file, and modify it for their uses? I mean, and then it also gets into this question of supported versus unsupported. We could put up all our designs and people could download them and modify them. But we say we make no assumptions about how they're used, you can contact us, but we'll just sort of say, this is what it is. We're not in the business of supporting modifying things to help the community. It becomes a tricky balance. So on the right, there's some examples of sort of these open repositories that are sort of makerspace or very sophisticated parts in that exist. And so you can download a part file, you can modify it, but you're not usually contacting the designer to say, hey, can you make this change? And so the big question we have is, can your business, or in our case, our business, exist in an open hardware environment? So it becomes a careful balance of how much do we share, at what cost, and how do we really do that? I mean, we want to participate in this community and be as open as possible because we believe in the science. And then the other flip side of this is a lot of our funding comes from the SBIR program, and projects are reviewed based on the intellectual property strategy. And so that is kind of can stand in contrast with the open science framework. And so that's something that we have to negotiate carefully, because we get a lot of funding to build instruments, and we also have to be careful on how we protect that. And so that's something we're very much considering. I guess that's
it.
And that's the end of our presentation. So I guess we open it up to questions. Thank you for your time.
Thank you. Very interesting insights here, and I'm sure it is definitely difficult to navigate this space, also being a business as well. Are there any questions from the community here?
I guess I have one quick question, and I really appreciate you guys presenting here, and I understand a lot of the constraints that you brought up and the interesting position it puts a manufacturer and a business in there. But can you speak towards open API's hackability as well? Because we're not necessarily, I mean, speaking as a member of the community who uses your equipment, I don't think we're necessarily looking for everything to be open. What I can give you the anti-example is when we get a bit of equipment and we find bits and pieces are dumbed down, or that we can't get it to do what we want it to do, even though we know it should be able to do it.
Yeah, I totally understand. And I think in most cases, especially on the software acquisition side, being open, like we always, if people want the code that operates the POPs, for example,
right,
it's C++ and we share it. The challenge, and I think the reluctance from a lot of firms to share too much is not so much that someone's going to take that code and sort of make another instrument and compete and steal business or take business away. It's more the time and effort needed to help support those customers. Okay. Like Ethan mentioned, we can say, hey, we don't, you want to change it, we don't support it. In practice, it is really hard to tell one of our customers that we're not going to help you. Like, we're sorry, we can't help you. And so, whether that folds into a higher price for the products with an understanding that we are going to support this hackability, whether the model is an optional package where you pay for sort of a yearly service to assist those sort of higher end users, or maybe it's something that the funding agencies can help support through the way, different schemes or different methods for these different business models to exist. The current business model is very much make a product, sell it, use that money to invest in new products and continue. Mm-hmm. There's not necessarily a lot of how do you support a hackable makerspace kind of world. There are examples in other fields, as I mentioned with the printers. And I think the challenge is for us to think about that and also get feedback from people. We try to be open, but we also need to mind the time we have available to help with that versus all the other things we're doing.
Thank you.